So our agenda for today is looking at some security planning. Obviously, we have to start somewhere. So thinking through some of the security issues that we might have is a very good place to start. There's also a bunch of secure configuration practices out there from Oracle, as well as different actual user presentations that are out available to look at and help with the planning of security in the database. The other way we want to look at some of these next points is what is sort of practical from our standpoint. Some of the documentation says we should have several different OS users and a lot of separation of duties, and that tends to work well if you have the different teams to do it. In smaller shops where you have a couple DBAs, that gets to be a little bit more challenging. So we'll look at some practical ways to implement that. And then what exactly do DBAs need for permissions is also a very interesting debate that we tend to have here as well. And knowing that there's different layers of security because one security solution really doesn't cover everything that you need to secure in your database. And so we'll take a look at those. So to start off, we're going to look at security and even why do we care. A lot of times it's something that might be thought of after the fact, or if you had a breach. Now we need to go back and secure information. Or it might be thought of very upfront, depending on the company you're with, and on the private, the assets that the company has for their information of the company. So because we're keepers of the data, we do care, even if not through the application itself, but what we can do on the back end of the database to add that security layer. Like I said, a couple of different security layers to make a secured configuration. So we care about private information, we care about the assets of the company. We also care about security incidents and not ending up on the front page of a breach or that costs extra to the company. We also want to look at regulations. I know we deal with the PCI, SOX, other HIPAA regulations for healthcare, and worldwide I know there's a bunch of different regulations that are always thrown at us. This I thought was an interesting fact. IUG does a survey, a security survey every year, and overall 2/3 of the companies either experience or expect data security incidents that they will have to deal with in the next 12 months, or simply don't know what to expect. And that to me is a very big number, and also means that security is coming up as a high point in front of managers and CIOs and companies themselves. So they're willing to put some effort and resources towards solving some of the security issues. If we look at planning our security, we need to look at the security goals that we have. So if we have the databases and we know we have certain compliance rules and regulations that we have to follow, those are going to be obviously ones that we're going to look at right away of what we need to do to meet those regulations. The other thing is the sensitive data that we might have. Do we have credit cards, social security number, even health insurance information, even sometimes names of people may be sensitive, or different vendors or different products that you're dealing with might be the sensitive data. This is also where DBAs need to get other people involved, because we don't necessarily always know what data we have and where it is. We understand we have this database, and we need to also look at where that data is being stored and the sensitive areas of that. There's the table space encryption that is new with 11G. Our 11G database has been really great for some of that, because you can actually encrypt at the table space level instead of the column level, which will help at least when the data to keep that secure. And we'll touch a little bit on that later. The other thing is, when you're meeting these security goals, who's actually responsible? I know DBAs sometimes grant access, and sometimes hand it off to the help desk to run scripts to grant the access and apply the different roles. But I feel even since we're administering the databases, we have certain responsibilities to make sure that the configuration stays secure, and the things that we've done on the database side make sense for the company and for the users and applications. We actually have a lot of in-house development, so some of that security ends up in the applications itself, but it's not, it comes back to the database. So you got to work with either the applications to know what is being secured there or what different solutions you might need on the back end. And in some companies, there might even be security administrators that come through and help with the auditing, help with setting up the security, and help with some of that planning. So which group is responsible for each of these goals is important to start off by planning. And then validating and testing and auditing. I think every one of the groups of people that are involved in security have some sort of responsibility in testing and auditing. And we'll walk through some different ways of testing some of the stuff on the back end of the database. Data classification is deciding where your sensitive data is. And this seems to be one that is difficult to do, and because there's so much data in certain companies and it's spread out all over the place, it may not be consolidated. And DBAs can really sort of suggest what might be sensitive data, but the data owners really need to validate. So not only do we have the roles of being administrators, but we also have this communication role in discussing, we understand we have sensitive data in this database, here's the things that we can do to encrypt it, protect it, do different things to make sure only people, certain roles have access to it, but we need to make sure we are capturing all the data that's sensitive. And then understanding also when we do apply encryption, and if it's company-wide data externally, that those types of education pieces are explained and communicated. So we're not just implementing a solution and then someone goes and downloads data to their laptop and you have all this private data exposed. So there's a lot of discussion of overall policies, which unfortunately can start with the DBA team, but definitely cannot be enforced always from the DBA's perspective. Definitely a team effort in some of this planning. And then you have obviously all the compliance regulations, and a lot of this really focuses on what rules are applied when you make changes, that things are validated, when you're granting access, who has the super user permissions, and there's very simple queries that you can go and run against that. And those types of queries or automated processes that you can create should be part of the planning to make sure you're meeting those regulations and compliance rules. You also have the separation of duties when you're talking about a lot of these compliance and regulations, that the people that have rights to change things in development probably don't have the rights to change things in production. And here you can have a debate back and forth of making sure that the security that you plan and implement in test environments is exactly the same as what you would do in production. So let's take a look at permissions and users and what makes sense, because we can really lock down the Oracle database and use it, basically almost have no real way for one person to have all the permissions to do everything, but that doesn't always make sense. There's a certain degree where you can allow separation of duties to administer certain parts of the database, but in smaller companies where you may only have one or two DBAs, that's more difficult to do. Also, you might have different roles, which makes it real easy to do. If you look at the OS security, you're looking at three different parts now of the database. You're looking at the grid and clusterware, which can have a separate OS user. You're looking at ASM, which is the automatic storage management piece, that can have another user. And you're looking at the database as being another user as well. And with those different users, you can either create those as separate users, or you can grant it all to Oracle and install with one user. What's nice about being able to separate this out is that if you have multiple databases on one server, you don't have everyone capable of that can administer those databases, everyone capable of shutting down the grid or shutting down ASM. And that's where it makes sense to sort of separate some of those duties out. If you have a smaller place where you really only have one or two databases on there, you probably have permissions to do everything you need to do on there. The different DBA roles also are applicable here with the sysdba, sysopper, and sysasm. So with sysasm in 11G, you can now you have to administer the ASM instance with that user. And so whoever has rights to do that can just administer the ASM instances and may not have permissions to the databases directly themselves. So these types of roles are good to separate out. The other thing is, too, when granting sysdba, you probably don't need the full permissions of sysdba, but you might want to grant sysopper, which allows you to shut down and start at certain times or allows those certain rights to be acquired at another time when needed. And then you have the database security itself, which is the permissions to the different objects and the role-based permissions, and even virtual private databases, which I'll show you some scripts later to discuss about that. But the role-based permissions is very important to add certain users and be able to grant objects by roles, and then you're almost monitoring just those roles for what has changed, and it makes it easier to administer all the different security options that you can actually select. The other big thing with the role-based permissions is when you're talking to the application owners, you can very easily discuss what roles are actually needed. And as they're discussing what roles you need, you can actually define those permissions appropriately and set those for each of the applications. And that way you have a good discussing point with each of those application owners. Obviously, with the database security and the access, you want to make sure that you're only granting the permissions that are needed. And that's where the roles come in handy, because that way you can give different levels of access. You want to make sure that permissions are configured the same as in development. And password management, that you have some way to expire passwords and keep that information. And you also want to have some role management where you're looking at the roles and managing how those permission changes and the auditing part. Security patches, I'm going to mention briefly here that it is a very important part of securing the Oracle database, and applying those patches are something that should be done fairly regularly, on a quarterly basis, maybe twice a year. DBA access, what makes sense DBA to have access to do the day-to-day job is always a good question. You know, first thing I normally do when I log into a new database or create a new database, I always create my own ID, so I'm not logging in a sister system. Those should not necessarily be logins that are used on a day-to-day basis. Those are special permissions. If I'm doing administration for parameters or patching, then I would need those permissions, but not regularly. You need the view of the dictionary to possibly look at information. You want to view sessions, and then of course the pieces of information where you're actually looking at performance tuning and being able to see what is running against the database. You may need to do some production migration, so you might need DBA permissions to be able to roll something out in someone else's schema. However, you can also trigger that through stored procedures with an alter current alter session state to current schema, and be able to change that and not necessarily have the full permissions, where you would just need to be able to alter your session to be able to do that. And then, of course, you need to be able to have enough permissions to run your backups and your statistics and your maintenance jobs that you're going to run. Another thing that you could implement is, and sometimes makes sense to do, because you're really protecting yourself as a DBA not to have the full permissions, where you can actually grant DBA to the user itself and do it and change it to be a non-default role. So then when you want to actually change it to do something where you're changing a parameter or anything like that, or looking into doing a migration, you can actually run a grab that information or change that on the fly, and where you're only really granting this permission to execute the stored procedure to that user, so you can change your default role to DBA. The nice thing about running a procedure or grabbing those permissions in this way, you can grab information about it and know if it was accessed, grab some auditing on this, which is great for those reports for compliance and regulation purposes. If we look at some practical auditing, again, some of those roles as you're changing them, if you're able to audit that types of permission changes, that's what people want to see. If you're able to put forth a report that basically says, well, really our DBAs have these basic permissions to see, they're not even really having DBA permissions, they only grant that when they're running through migrations, and you can show when those permissions change through a script. Those are good things to lay in front of auditors and very simple things to audit. You can also track users on roles based on role changes and when users are granted those particular roles. And you can also change, and as you're changing employee lifecycle, when the roles change, to make sure that you are, when someone's job changes, you're changing the role and permissions that they have in the databases. And again, the permission changes on grants, you can run queries against the DBA tables to get that information and change that. You have database access for DBAs and administrators, which may be an issue depending on the sensitive nature of your database. You also have worries about some internal attacks for people having more access to systems that they shouldn't have. This is where one of the Oracle database options of the database vault comes in handy. And you also have, we'll walk through real quickly how to do that. Permissions to handle migrations, you need to be able to handle that information to be able to roll out code to production. It may be different production DBAs where you're having separation of duty to do that. And you have masking of data, that's an option, so you're not looking at the sensitive data. So some of the advanced security options for Oracle are that transparent data encryption. You have identity management piece that can be hooked into applications that's defined on roles and responsibilities. You have the database vault, which actually does limit the amount of data that the sysadmin or the sysDBA can see. And you have auditing that you would want to have for your compliance and regulations. Again, a combination of security features is important because even if you have a database vault and your sysDBAs cannot see the data when they're logging in and accessing the data through select statements, you can still see the data on the back end of the database if you actually read through those data files. So you would want to make sure that you're doing some sort of encryption on the stored data or the data files, and that's where that transparent data encryption, where you can actually encrypt the table space, makes perfect sense to implement on that side. You also have virtual private databases where people can access through certain rules of policies to make sure that they're only accessing what they're going to be accessing on top of that. And again, auditing is always a big thing. So if we look at the transparent data encryption, it basically encrypts the data files and by table space. You can also do column-based encryption, and that is something that would be necessary to handle on some of the application side of things, but the table space encryption really is transparent. And then you have also encryption with secure database backups. So what is needed for database transparent data encryption? You need a wallet that holds the encrypt and decryption keys. This basically is used when you want to open the database. You do not want to necessarily lose that wallet password. That's important to keep because otherwise you're going to have issues opening the database and having these table spaces fit on the way out. Real simple to create a table space with encryption. You basically set encryption and default storage to encrypt. And then anything that you put into that table space will be encrypted when that data file is at rest. And when the database is open, password, that data is decrypted inside of the database, so when you're logging in and looking at it, you will see all the full data. The database vault is another good option, and it makes sense if you have very, very sensitive data that you want to allow the DBAs to continue to do their jobs and not allow them to see certain pieces of information. What's nice about this is you can create realms to define the access. This is where you get some of the security administrators involved, where they may be granting access to these realms or creating the different realms. And this is what's managed outside of the database. You can install it as an option with the database, and then you have certain administration tools that allow users to add and manage, or to manage these realms, and as well as manage users. Again, after you create a database, you're using your database configuration assistant to add these options. That makes it very simple to do. And you can validate your install. What's nice about this is it's something that you can script and expect a certain result to always come up. And when you have that result type of query that you can run, you can set it as one of your post checks of, like, after you're done patching, to make sure your database vault is turned on again, to allow for that, to make sure that your options are not turned off. And this also allows you to query the database to make sure that you do have the database vault on. And it's a simple tool, just like OEM, to use to create realms and administer the database site. It's something simple for the DBAs to maybe look at and take a look at, but it would take some training on if you're using other teams to create the realms or to create the users. And again, these could be separate, different users doing each of these different tasks, so no one is allowed to really create their own user and grant the permissions that they need. These are actually divided. So that's what's providing you with the separation of duties and with the database vault, and allows the sys-DBAs to do their job as they need to do their job without having and seeing all the database. And you can have administrators and or managers these separation of duties to create the users, and then someone else that actually grants them to the realm. What I find also very useful, even though you can't see the data as a sys-DBA, there's a lot of application users that have access to the database and may have access outside of the application itself. This is where some of the virtual private databases come in handy, to be able to actually put a where clause on the database or on the tables without the user having to put the where clause themselves. Because this way, when you log in, you are defined by a policy by either department, job title, maybe by user itself, to know where you actually have access. And if there's a sensitive table with data, then it can restrict that without having that as part of your query statement and relying on users making sure they're only accessing the data that they're supposed to. To implement the virtual private databases, it's really just creating triggers and policies in the database. And, it protects and restricts the data inside applications as well as the ad hoc queries outside of these applications, or rows or other values on objects. So in creating the policy, let's just walk through some of this. It's really, you can create basically a logon trigger, which will allow you, my logon trigger, which will set your role after you log on to the database. So anyone logging on will get the role set, and then based on the different policies that you can create this policy with on an object, and you then have a policy function, which is that role that you've just granted. And then you can have statement types. And right now, this is only protected against select statements. That means if someone has permission to run inserts, updates, or deletes, that they would be able to see the data that we just restricted them for the select policy. So the statement types can include all the select, inserts, updates, and deletes, and should also be considered when you're creating these policies. And then you have a procedure that will basically set those roles based on the role name that you can use for your code. Again, testing can be set up to validate what you've done for a virtual private database. For the vault administration, you can do queries against the realm data by the system account and validate the response that you get back, and set a script up either some sort of wrapper that you would normally use, or schedule it in the database even to let it run and produce your reports for auditing. You can change the realms and access. Again, these queries can be run against the realm data to validate and test plans even for the virtual private databases. So for example, here testing can be set up. You log in as this DBA. I want to select from this table, and I get insufficient privileges. So that right away demonstrates that I am not part of that realm. Even when I'm logged in as this DBA, I can't access that table. And then the other way to test, you have test plans that can show that you have permissions, and you get different messages depending on that information. It could be part of your unit testing, regression testing, and especially after changes that you can go through and run through where you're double checking if you have the permissions they have changed, as well as if you still have your virtual private databases in place on those specific objects and policies. So for example, if I have a test user and I only have certain permissions to a table, I will only see a certain number of rows in that table. So when I select from it, I get a different count as if the person in that that's allowed to see the whole table can get that information. What's nice about sort of knowing at least a little bit about table statistics, you can actually select the number of rows from the table statistics table, as long as you're making sure that your statistics are up to date and these numbers are different. You sort of have validated that there is a restriction there on that table for that test user. And that's at least a rough test to make, but it's a way to validate that at least some things are still in place and there's controls around that security, which is a lot of times what you need to do for auditing and the compliance rules. So practical auditing is also another big thing, because when you look at auditing, you can basically audit everything that's going on in the database, which will cause pages and pages and pages of reports, or if you're not printing them out, which hopefully not at this point in time, but it's several megabytes of files to go through, and then makes it very difficult to review. So it makes sense to create reports that make sense to review. So if you're looking at changes and you're looking at what is going on, you're making sure that you have certain controls in place, which goes back to that security planning of knowing what your goals are for the security. You're definitely auditing the DBA roles and those people that have super user permissions, and validating those permissions of development versus production. So you may have permissions of a development person and making sure that they're not in production to be able to make the same changes, or you're making sure that you have the exact same permissions in both. But this is something, if you're auditing, you're looking really at, you want to know what has changed and capture that result. These are basically, you can run queries against audit tables to get your reports. The nice thing about that database vault administrator piece, it actually has not only the auditing for the vault itself, but it also has auditing, the general auditing for the database too. You can also use the audit vault, which will basically lock down any of the audit logs. And again, depending on your security goals or policies, it may be a requirement for the DBAs not to have any way to access and change these audit tables or reports. And then make sure you know who's reviewing them and they get in a format that they want to see. Real quick on the auditing, 11G turns it on by default, and this is what they turn on by default. As you can see, a lot of it is has a lot of permissions or a lot of auditing around what has changed. So if you're altering, creating, dropping tables, granting access, these things are automatically audited by default when the database is created in 11G. You have audit trails stored in two different places. There is the Vault audit trail as well as the regular DBA audit trail that you will have both places if you're turned on Database Vault to do auditing. So this is a separate, the Vault, even if you turn off database auditing, your Vault auditing is still turned on, so you have access to see that information. And again, here's just an example of what different objects, the different names, everything. You got your created your timestamps and everything against it to pull those reports. So whether you're doing queries or you're going in through the OEM tool here to go and access those CAN reports, you can get your general security reports and make it easy for someone else to review and take a look at. So basically, to summarize some of this, there's a lot of different options, a lot of different places where you're going to be looking to secure the data, looking at encrypting database table spaces where it makes sense, encrypting columns where it makes sense, and especially only granting permissions that are needed. You have several options in the database to turn on with options for Oracle and the advanced security options, and really implement what is necessary. So as you define your goals and the security information, make sure you're fitting that to what your goals are. Policies and practices outside of the database are just as important as what you have in the database, because if someone's pulling data and throwing it up on a shared drive, a lot of your vault stuff is then null and void at that point because anyone can access it. So make sure it's understood that you've secured and locked this data down, and make sure you just have those discussions about what's being done with it outside of the database. Practical implementation to be able to continue to do your job. Even as a DBA, you want the least privileges that you need to do your daily job and maintain that secure configuration. If you need to turn it on, then it's a logged event if you use like a stored procedure to grant yourself access, and that makes perfect sense to run the job that you need to do and then turn it back off again. So you're able to just do your regular daily job without the excess of that you need. And obviously auditing these changes. Even though that the DBAs are not completely responsible for all the security in the company, we definitely need to understand some of the options that are available, even with firewalls, even options inside the database and outside of the database, and make sure that some of these features are working together, because there's no real one simple solution to secure everything. So you're normally having to apply a couple different security features to lock down the information that you need to. And again, there's quick and easy ways to validate installs and implementation of these features, and to test as you're going and doing changes. So you can include some of these queries in PostScripts after migrating changes to be part of a regression test. And it's a simple, easy way to just validate that the permission hasn't changed or that the access still is the same. And it is teamwork. It's not just the DBA teams solving sensitive data issues or even the compliance issues, but it's support and behaviors from the enterprise to implement this. And Tom, I think I'm ready for some questions if there's anything out there.
Okay, well, no questions have come in, so I can only conclude that Michelle's presentation answered everything that you needed to know about DBA secure configuration. I thank you all again for attending, and please come back and join us again for the next webinar. So thanks for your time again today, and if you do have any questions, you can email in to Redgate, or you can probably contact Michelle directly. Okay, thanks very much. Bye-bye for now. Bye-bye.